welcome to my introduction of the Latin square design topic. So, what is Latin square design? Latin square design is a statistical tool that we use to control variation in an experiment related to rows and columns. This means that you're controlling variation in two directions. So, for example, for a one Latin square design, you could have a 3x3 design with 3 factors, and you can complete that in just 9 runs. Or you can have a 4x4 design of 3 factors and run that in 16 runs. Obviously, there's a bunch of different configurations, but this is just a couple ideas that I list about. So, how do you represent the data for Latin square designs? It's simple. You have your rows and you have your columns. Here, the columns are control 1, 2, and 3, and your rows are day 1, day 2, day 3, and day 4. Then you have your treatments and your factors of interest, and those are going to be represented by A, B, C, and D. Now, what makes Latin square designs unique and excellent to use in terms of efficiency and testing different treatment systems is the fact that in each row you can only have one of each treatment, and in each column you can only have one of each treatment. This maximizes your total runtime, and it makes it a little bit easier to figure out a couple different things that we'll go into next. And this is how you interpret the data that you had just received. So, ANOVA analysis. You have your source of variation, your rows, columns, treatments, and error. You have degrees of freedom, sum of squares, mean of square, and F. This is essentially a way that you derive different statistical analysis of your set of data, and you can pull out a little bit of information that you wouldn't typically see if you were just looking at the set of data per se. So how is this applicable to engineering? Well, as we mentioned before, when you want to control variation in two directions, Latin square designs is the way to go. It tests several parameters with just one method, utilizing the treatment system. It decreases net experimental runs. It delivers efficiency to the total developmental process. The results even give a smaller mean square of error, and it's simple and a defined analysis. So, if you have multiple parameters, you want child reduction, and you're looking for an error source or a solution, Latin square designs are the way to go. If you take anything from this, take the fact that it's efficient, you reduce the number of trials, and you have control in both the row and column, aka two directions.